Okay, rational functions. Okay, when you do rational functions, you need to analyze two things: the vertical rules, the domain, and the horizontal rules. Okay, so first thing is the non-permissible value. What's not allowed? -1. -1 is not allowed. Would it be considered a vertical asymptote or a hole?
Vertical.
Vertical asymptote. Also, you guys understand the name for a hole is the point of discontinuity. That's a hole. Okay, so first of all, I'm going to go -1. Vertical asymptote. Sometimes they might just say, what's the equation of the asymptotes? And you would write x equals -1. Okay, now let's talk about the degree. What's going on? Higher, same, what do we know? Higher on top tells me nothing. Doesn't matter. And range can be anything. So now when you graph, you pick a few x values. So x, I would do 0 and 1, a couple on that side. And I would do -2 and -3. Okay, so let's plug that in. So if x was 0, I'm just going to cover them. If x was 0, you would get -4. If x was 1, you would get 1 squared minus 4, -3 over 1 plus 1. So -1.5. Whoops, what am I doing here? Oh, I don't even know. Maybe I'm going to do another one here. What if you plugged in a 2? 2 squared is 4 minus 4. Well, that's going to be 0. -2 plugged in. -2 squared is 4 minus 4. That's a 0. -2 plugged in is 0. -3 plugged in. 9 minus 4 is 5 over -2. So -2.5. Okay. How would you write the, let's just do domain, because range is -infinity to infinity. So how would you write the domain if I asked you to write it? You could do it in two ways. You can do this from -infinity, and then you get up to -1, but can't be on. Then you can jump to the other side of it and keep going. Another way to write that is x can be anything except not -1. X can be anything except. Okay, and then this one. I should have given feel like I should just give a different question here. Let's just change it so I can get more of the rules in here for you. Make sure you cover them all. Oh, you know what? Boom, forget it. Flip the page.
Oh.
I see there's another one here that will cover them. Yep, that's all. All good. Oh, let's just talk about, sorry, I just really messed this up. The original one, let's not do it, but let's just talk about what we know. How about we just say the properties of it? I think that's...
Oh, line.
Okay, so let's just talk about the properties of that one. Now that I've all messed it up. You would, what do you know with X? You would have a vertical asymptote at 1. Okay. Then what do you know about the degree situation? It's the same. So what do you do when they're the same? You divide the coefficients. So 5x divided by 1x, that kind of idea, is a horizontal at 5. Okay, that's kind of the idea, right? 5 at 1, and then and then you plot some points, okay? Okay, so understand the rules. Okay, so this one is the one I want to do.
Are we just doing the same thing as the last one, or are we actually doing this one?
We're doing this one now. Yeah, sorry, I should have peeked ahead before I... Okay. So before I start the rule process, I need to understand what's on the bottom, so I need to factor. I need to factor to get that. So there's my factors. And -3 is going to be a what? A vertical asymptote. And -5 is going to be a hole because of cancel. So maybe we want to do this, -5 comma something, because we will need the coordinate of the hole. So on your exam, please make sure if they say what is the coordinate, then you make sure you do the whole thing, okay? Okay, simplified. What are we going to do to simplify it? If this canceled and this canceled, that's the equation simplified. Also, we have to go through the degree analyzing. So what do you think about the degrees? You can look here or here, doesn't matter. Do you have same, more somewhere? More on the bottom? So what do you do if there's higher on the bottom? 0. Okay, so there's all your stuff. So 0, -3, okay, so why don't we, this is why we did this open, so that I didn't forget. Where is the hole? If you plug -5 into that, -1/2.
I meant to say it.
-2 on the bottom. Okay, so I'm going to put that in there right now. -5, comma, -1/2. Open hole. How about you plug in a -4, making -1. Do you know your shape? Are you drawing your asymptote approaching 0 and not curling away or touching kind of idea? As careful as you can. I would also plug in a -2. You can do -1 or you can do 0. 0 is easier. If I do 0, I get a third. If I do 0, I get 1/3. There you go. Okay. Domain and range, you might be asked questions related to that stuff. So domain, you can go here, and then the first time you make a skip over a number is at -5. And then you continue again up to -3.
No, you can't on this one. Wait, can you do x can equal -5?
X can be any real number except -5 or -3. I would accept both. And the range, you would go, I'm going to just write it like this. What are the things I need to skip over on heights?
-2.
-1/2. Y can't be -1/2 or 0. So then, if you wanted to write it like that, same thing, go to -1/2, skip, -1/2 to 0, skip. Okay, that's it with rationals. Those are the big ideas.
All right.
Vertical asymptotes, holes. Degree analysis, higher top, don't worry, same, divide, higher bottom, 0. Got it? Okay, so then radical stuff. Okay, I won't even touch this right now. Why? Does it look like that? No. Can we move stuff around before we attack it? -1 out of that. I don't like the negative x. So then it would be x -5. So where would you start this radical? Yes, and up to. And what else there? Right 5. So then I would start at the coordinate 5, 2. How do radicals move in a pattern sense? Over, up, 1, 1, 4, 2, 9, 3. Right? The flipped of what squared is? Square root. Okay, I'm not going to do this though. Why? Because there's a b. What does a b value do in this chart? Where do I apply a b? To the x's, and what do you do with a b to an x? Divide by the b. Be careful, what if you're dividing by a half? You times by 2, right, or whatever. So I'm going to move left 1, up 1, left 4, up 2. Am I good with domain range? You guys can do those things? Your pros? Okay, a couple more and then we're done. Find the equation of a radical. So this is the domain. So we're headed in that direction. And the range is heading in a upward direction. So then if I put those ideas together, I need to head left and up. So there's my radical. I'm heading left and up according to what they gave me. So I need to do an equation of a radical. Okay? How many of you on an exam are going to forget to put an equation with something like a y equals or an f of x equals or whatever you need to do? Don't forget. Okay, I'm going to leave room in my A and my B position because I don't know. I'm going to go x subtract 2 to show that I've moved to a positive 2. And I'm going to go minus 3 to show that I've moved down 3. And ask yourself if this is the direction radicals should go. No. What's a normal radical? That's a normal radical. Normal us. So there's been a reflection, so now you have to decide if that's an A or a B reflection. That would be a B, and then that means I need brackets now. Okay, find a rational, which means I need a fraction. Understand the words. Radical, square root stuff. Rational, fraction stuff. How do you put a whole at 2? You need a cancel. And then what is the factor then? Boom, whole. Check. We're done our whole. We need a vertical asymptote at 6. So that means x minus 6. Check. How do you make a horizontal asymptote at a specific number? What's the situation with the degrees? What are they doing? They're doing the same degree. Okay, now, are they the same degree right now? No, this is an x and this is an x squared. So what could we do? Times by any more x. You can just do x, you can do x plus 10, whatever. But I need this number to be a 2. So something divided by something in the front needs to make a 2. So you can do whatever you want. You could do like a 20 and a 10, or just a 2 on the top. As long as your numbers divide by and get 2.
This is our last unit.
I don't know. I think so, or no?
I'll check.
I think.
Oh yeah, we got, oh no, we didn't.
Are we good?
I think so, actually.
Okay, solving this algebraically. So isolation, I'm going to do an add 4.
Oh, we used.
Divide by 2. Then I'm going to square Okay, so now I'm going to graph this. So this has moved left 5 and down 4. Left 5 and down 4. One, 1, 4, 2, 9, 3. So the transformation now that I deal with is the 2, and it's attached to which letter position? And it's attached to the A position. Yeah. So then what do I do with that in my chart? If it's an A, I times y's by A. So this is a 2, this is a 4, and this is a 6. So I'm going to go right 1 up 2. 1, 2, 3, 4, up 4. And guess what happened here? The x-intercept is -1, 0, which is good because that matches my algebra. Aha. Depends how they word it. If they say what's the coordinate of the x-intercept or something like that. Okay, so this one is a radical of a graph. So what do we know about square rooting? Anything you know about square rooting? Square root a negative doesn't work. So guess what I'm going to think about? That wouldn't exist on my final graph. Negative heights. I'm looking at the heights, right? What else do you know? There's some points that are invariant, so you better know how to apply that. What would you be looking for with an invariant? Where y is 1, what else? Or 0. So there might be an application question in find the coordinate that's invariant, and they might give you an equation. That means you're plugging those in. On this graph, that's what I know on the graph. Those are invariant. Okay, now looking at where my pen is, the heights in this zone are between 0 and 1. What happens to a number when you square root it? If it's between 0 and 1 and you square root it, what happens? It gets bigger. So now I'm above it. And I'm actually going to go over here and take something specific. This point is 4 height, so it should go down to 2. And if your graph stops, you stop. If your graph has an arrow, you have an arrow. So be careful, right? You know what I did on your test? For a provincial exam question I put on your test and hardly any of you got it. What was the domain of the square root of x squared minus 16? What's the domain of this?
X. How do you go forward?
Okay. Well, what do you know about the equation y equals x squared minus 16? Without the radical, what do you know? Parabola, where? 16 down. Okay, so you know that. So break it down. Now, if you square root this, where can't you square root? You can't do this. So I can square root this stuff and this stuff. So what would the domain of that situation be? Do you know what this specific x-intercept would be there and there? This would be at a -4 and this would be at a 4. So negative infinity to -4, or you could do the other side. And you can be a square bracket, right? Because you can square root a 0. Do you remember that question on the test? Because a lot of you did not get it. I also gave you another question that I found hard on a provincial, which was name the invariant point on name the invariant point on that. So you could go about this if you're a graph person or an algebra person. You could do it either way. So if you were a graph person, what do you know about this? What is the shape of it? A line. So what point would be invariant? Where there's a height of 0 or 1. If I started at -3 and traveled up over 1, up over 1, what is this coordinate if I keep doing the up 1 over 1? You'd get to 3. And if you kept going, up 1 over 1, you would be at 4, 1. If you were an algebra person, what else could you do? You could just plug, let's say, 1 in there and solve. You could be like this, 1 equals that. And then how do you solve? Square it, add 3. Square it, add 3, and then I would probably see a lot of mistakes because the question asked me for a coordinate. So 4, 1. Okay, that's the idea. Okay, so don't always forget your basics. If there's something linear, you know what that looks like, and then you can figure out stuff from what you know about linear or quadratic stuff.